In the past, human beings entering space was already a world-renowned achievement. But with the rapid development of aerospace technology, we are now not only exploring space, but also able to bring back some precious experimental samples from the moon and space. Recently, China once again broke the routine and made a bold attempt to grow rice in outer space. In December 2024, China announced that their third-generation space rice planting experiment was successful, and it is expected to usher in a bumper harvest in 5 months. This breakthrough marks another major progress made by China in the field of aerospace. However, as one of the pioneers of global aerospace technology, some aerospace experts in the United States have questioned this. They believe that although this experiment is technologically epoch-making, a lot of money and resources have been invested, and it seems that there is not much practical significance to do such an experiment. After all, who would eat rice in space? Moreover, the yield of space rice is far from enough to solve the growing food crisis on Earth. But is the problem really that simple? Next, follow my steps to explore why China is conducting rice planting experiments in space and what profound meanings are hidden behind this experiment. If you like our video content, please click to subscribe to my YouTube channel so that you can receive all our latest video content. Now, let's get into today's topic. Do you know? China's space industry officially started in 1956, just like a baby in swaddling clothes. But at that time, the United States had already begun to study the development of liquid rockets, laying a solid foundation for the subsequent development of space technology. It stands to reason that China's gap with the United States at the beginning was so large that it seemed unlikely to surpass the United States' leading position in the field of space. After all, the starting point gap was too large. But the facts were unexpected. In 1970, China successfully launched its first artificial satellite, Dongfeng-Hong-1, with the Long March 1 carrier rocket, becoming the 5th country in the world to independently launch an artificial satellite. Then, in 1975, China successfully launched the first recoverable satellite, becoming the 3rd country in the world to master satellite return technology. According to reports from China's official media, since 1956, China's space industry has gone through several stages of development, and the investment has increased year by year. In 2022, the United States investment in the field of space accounted for about 0.24% of its GDP. As a developing country, China's research funding in the field of space is as high as $11.94 billion, and the proportion of the aerospace industry to China's total GDP is about 1%, ranking 2nd in the world. This figure even exceeds the GDP of 46 countries, which is really unimaginable. It is precisely because of such great efforts that China's space industry has ushered in a new peak after entering the 21st century, successfully solving technical problems such as astronaut extravehicular activities and spacecraft rendezvous and docking. In 2003, China's first manned rocket Shenzhou-V was successfully launched, marking that China became the 3rd country in the world to master manned space technology. With the launch of manned rockets and the advancement of space laboratory construction projects, China's space industry has made rapid and amazing progress. Slowly, China began to turn its attention to the moon and began to study how to successfully land on the moon. In this process, they encountered 4 major problems: orbit design and flight process control, 3-vector problem of attitude control, satellite environmental adaptability design, and technical bottlenecks such as long-distance measurement and control and communication. At that time, the United States imposed a technological blockade on China, which greatly restricted China's research progress, and many key technologies were stuck in bottlenecks. Later, after the unremitting efforts and independent research and development of Chinese scientists, China finally broke the U.S. technological blockade. In 2007, China launched its first lunar probe, Chang'e 1, which marked China's official first step in lunar exploration. Since then, China has continued to make remarkable achievements in the field of aerospace. And as of today, China has the strength to compete with the United States. However, China's ambitions in space exploration go far beyond this. In 2020, they began a shocking space experiment growing rice in space. Some people may not understand why such scientific research is being carried out, and even feel that this seems to be a meaningless experiment. Others believe that this is China's preparation for long-term exploration of space in the future. So what is the truth? Historically, China is not the first country to want to grow rice in space. Other developed countries have also conducted similar space agricultural experiments. The United States is one of the first countries to conduct spaceplant experiments. As early as the 1980s, NASA began to conduct plant growth experiments on the space station, including rice research. However, after 3 years of research and billions of dollars, no significant research results were achieved. Therefore, European and American countries are not optimistic about China's space rice experiments. After all, space breeding faces two huge challenges. One is the microgravity environment, and the other is the gene mutation that may be caused by cosmic ray irradiation. This special culture condition is extremely difficult and cannot be overcome in a short period of time. Even the United States, which has rich aerospace experience and high-level scientific research capabilities, has no choice. Thinking about this difficulty, it really makes people feel almost impossible. In order to conduct the experiment smoothly, China's aerospace department initially tried to cooperate with the United States to seek technical support. However, Sino-US relations were not friendly at the time, and China was regarded as a threat by the United States. So, the cooperation request was rejected. Subsequently, the United States also imposed a series of technical blockades on China, which undoubtedly dealt a heavy blow to China in scientific research. But China did not give up the dream of growing rice in space because of these blockades. On the contrary, they began to conduct research day and night, focusing on solving various technical problems of rice growth in space. After more than a year of continuous efforts and accumulation, in June 2022, 6 Chinese rice seeds entered the Chinese space station with the Shenzhou 14-man spacecraft, which also marked the official start of China's space rice experiment. However, during the research process, researchers found that rice faces great challenges in growing in a microgravity environment. Rice seeds began to show space syndrome, such as slow growth, sluggish seedlings, and even lacking the upright and healthy appearance on Earth. At the end of November 2022, after a total of about 120 days of experiments, the final harvest was only 59 seeds. Although the results of the first generation of space rice were not ideal, it brought hope to China and proved the feasibility of growing rice in space. And this experiment began to attract the attention of some countries. So how did China's rice grow successfully in such a harsh space environment? As far as I know, Chinese scientists will strictly select the first batch of space rice seeds before conducting experiments. They usually choose varieties with short growth cycles, strong adaptability, and high yields, and they must ensure that they are free of pests and diseases or other undesirable genes. Scientists will also process these seeds in advance to adapt them to the space environment they may encounter in the future, such as low temperature and low gravity. Then, these seeds will be placed in special containers and launched into space with the spacecraft. In space, seeds will be affected by conditions such as microgravity, strong radiation, and low temperature for several months, all of which may affect the genes and growth of rice. Through this experiment, scientists hope to understand whether these extreme conditions will cause gene mutations or changes in gene expression, thereby improving rice's stress resistance, yield, and other characteristics. At the same time, they will also monitor the germination process, root growth, leaf development, and other conditions of rice seeds. Since there is no gravity in space, plants may show different growth patterns. Regarding light control, There are artificial light sources in the plant growth cabin of the space station to simulate the sunlight on the Earth to support photosynthesis and normal growth of plants. According to relevant data statistics, the temperature must be above 20 degrees Celsius when planting in space to ensure the steady growth process of the seeds. Another point that cannot be ignored is that the seeds can drink enough water through capillary action. After all, leaving water is basically equivalent to failure. Therefore, the photoperiod and light intensity will be precisely controlled. Finally, liquid culture medium is used to provide water and nutrients. In a microgravity environment, the way water and nutrients are transferred will change and need to be managed through a precise system. It is this stage of research that has also provided Chinese scientists with valuable data to help them understand the growth laws of rice in a weightless environment. So when the experiment is over, these rice seeds will be brought back to Earth by the Shenzhou 14-man spacecraft for ground experiments and compared with ordinary rice to see if they have some special performance and growth, such as disease resistance, insect resistance, drought resistance, and other characteristics. By observing and collecting data, Chinese scientists will analyze the performance of space rice. Generally speaking, the space environment may cause genetic mutations or change certain characteristics of plants. These changes may be used in subsequent breeding efforts to improve rice yield, stress resistance, and other quality traits. But did you know that China's first batch of space rice seed experiments was just the beginning? Subsequently, Chinese scientists selected more stress-resistant and higher-yielding rice individuals from the first generation of space rice. The second generation of seeds was improved based on the breeding results of the first generation. Scientists further enhanced the characteristics of rice stress tolerance, disease, and pest resistance, and increased yield through conventional breeding or gene editing and other technologies. Because these seeds are very precious, researchers propagated some of them in the artificial climate chamber of the Center for Excellence in Molecular Plant Sciences of the Chinese Academy of Sciences to observe whether these seeds perform better than the first generation of seeds in a conventional environment. Usually, they will conduct a comprehensive assessment of the growth cycle, yield, and disease resistance of these seeds. It was not until December 2022 that China's second-generation space rice seeds were finally propagated on Earth. Researchers carefully compared and screened, recorded the data of mutant plants, and continuously corrected the experimental data. After more than 100 days of careful care, scientists finally waited for a good harvest. This time, they successfully collected nearly 10,000 second-generation space rice seeds. The experimental results of this stage are a huge leap forward. Compared with the first generation of space rice, the second generation of rice performs better, especially in terms of disease resistance, drought resistance, and salt-alkali tolerance. In addition, this study also shows that under the conditions of microgravity in space, rice seed embryos develop normally and can develop into vigorous offspring. The number of tillers of the second generation of space rice plants is significantly higher than that of the ground control group, proving that viable rice seeds can grow in space. And these seeds still have the ability to reproduce after returning to the ground. Then scientists selected the best plants from them for further breeding, gradually stabilized these excellent characteristics, and laid the foundation for the subsequent third generation of space rice seed research. However, China is not satisfied with the existing research results. They hope to further improve the quality and yield of space rice. So they began to study the third generation of space rice, and this time the focus of analysis is on its yield and nutrition. After more than a year of preparation, in 2024, they began the third space rice seed research. Researchers will select a part of the second generation of space rice seeds and plant them in the fields of the farm of the Chinese Academy of Sciences. The key to this process is to ensure that the environmental conditions, such as moisture, temperature, and oxygen, are suitable to ensure that the rice can grow smoothly. After several months of careful research, It was found that the survival ability of the third-generation space rice has been effectively improved. The yield is higher, and it has shown a super advantage in adaptability. In addition, data show that the third-generation space rice has significantly higher glucose and fructose content than ordinary rice on Earth, and the starch composition and protein content have also changed significantly. What is most exciting is that these rice may be sweeter and more delicious than ordinary rice, bringing a richer taste experience. However, as one of the pioneers of global aerospace technology, some aerospace experts in the United States have questioned this experiment. They believe that although this experiment is technologically epoch-making, investing huge funds and resources to do such a thing does not seem to have much practical significance. After all, who would eat rice in space? So, do you know why China is conducting rice planting experiments in space? In fact, since the 1950s, human exploration of the universe has never stopped. However, although humans have carried out activities in space stations, their resources such as food, water, and oxygen still need to be transported from the ground, which not only involves huge costs, but also in the future, as the exploration of outer space deepens and the time is extended, how to solve the problem of survival in the outer space environment will be more urgent. The success of China's third-generation space rice research, of course, provides innovative ideas for solving this core problem. However, as a developing country, why don't China use more resources to develop the economy, but conduct rice planting experiments in space? This is to return to China's historical origins. From ancient times to the present, China has been a country dominated by agriculture, a veritable agricultural power. According to statistics, by 2024, China will account for about 25% of the world's total grain production and is one of the world's largest grain producers, especially in the production of major grain crops such as rice, wheat, and corn. The numbers will tell us that China is a country with rice as its staple food, with an annual rice consumption of about 142,700 million tons, accounting for nearly 30% of the global rice production. According to the data, the average annual per capita consumption of rice in China is 358 kilograms, which means that each person eats about 11,622 grams of rice per year, equivalent to 1.7 kilograms of rice. Therefore, it is not surprising that China conducts rice planting experiments in space research, because it is closely linked to China's agricultural tradition. Now, with the success of China's third-generation space rice research, they may continue to carry out long-term space rice planting experiments in the future to verify the growth, flowering, fruiting, and other life activities of rice in different space environments. Future experiments in rice cultivation in space may combine gene editing technology, and Chinese scientists can study how to improve rice growth performance in extreme environments through gene modification, especially in terms of drought resistance, pest resistance, and increased yield. With the impact of global climate change, studying the performance of rice under different environmental pressures, especially rice stress resistance and resource utilization efficiency, I think this is an important direction for China's future agricultural development. Today, from the Chang'e series of lunar exploration to the Tianwen Mars exploration, and now to the space rice experiment, each breakthrough indicates that China is challenging the United States' dominance in the history of space exploration. Of course, in addition to rice, China may also plan space planting experiments on other crops in the future, such as wheat and corn, to study their growth and adaptability in the space environment and provide support for the food production system of future space stations. In addition, China has always maintained an open and cooperative attitude, so they will continue to carry out extensive cooperation and exchanges with other countries and international organizations in the field of space exploration. To not miss out on our future projects and news updates, please make sure you subscribe to our channel and turn on notifications. We will continue to provide you with more exciting and interesting content.